Hello, everybody. My name is Nikolay Malitsky. Today I present the proposal of next EPICS data storage. So the few words about the EPICS. This is a control system used in many accelerator projects in the world. United States, for example, is just used in the majority of the national labs in the SLAC, Berkeley, Los Alamos, Argonne, and Oak Ridge. And the next slide that presented an SLS2 built in the Brookhaven National Laboratory. So in the short, accelerator project is a big enterprise involving the many different the system and also encompass of the various heterogeneous physical devices. So the new project coming with the new challenges, and eventually we're coming up to the new scale, like 1 million of streams of time series that we need to collect in the database and archive. So for the post-processing, the analyzing, troubleshooting, and also for commissioning of the operation. Rephrasing the statement of the previous, yesterday, so certainly relational database is a scale, but don't scale very well, okay? So we really need new technologies to solve this problem. So EPICS likes challenges, and so looking also around for the new application. This one is an example of a beamline data acquisition system that coming together with the accelerator projects. So again, new projects coming with the new technologies, and you can see like detected data rate of for the new facilities on the scale of the 50 gigabyte per second. This is a really enormous rate. So this data, of course, is a process of online in runtime environment, and also in with the usually tomographic application is just coming with the 3D imaging that we need to store in the file system. So we're working with the scientists, and we have some progress. It's hard. So eventually we're coming with a common data format that's going to use for the different experiment. So, but again, so this is a very similar problem that Ralph presented yesterday. So that we need some common service to work with multiple files. In addition to that, these files also correlated with the control data, because experiment is quite difficult, and certainly the settings is really important, and they correlated with the scientific data. So again, so we need some common solution. So that after the analysis of several technologies, eventually that I found that, and pleased to find that this is a very natural solution suggested by the XLDB the team. They call array-oriented the conceptual model. So frankly, I'm looking for some more approach for the several years. From my perspective, it's a really natural step in the evolution of column-oriented databases. So in addition to the natural representation of the previous use cases, this XLDB project coming with a very efficient interface, integrated very important features like column-oriented approach, chunk-based approach, and many others. So that after the sourcing, after analyzing the source code and the several different benchmarking and the prototyping our system, eventually came with some proposal of integrated system. Okay, so that it presented 2 weeks ago at the EPICS collaboration meeting in Switzerland, and very good accepted. In short, using that. Again, so the middle term in the in-situ database approach, we expect to use the XLDB as a common platform to connect all different subsystems in our environment. Actually, so to bind together the past, present, and future. So from the different perspective, it's also very interesting. So because we consider XLDB will be another service. Okay, the first of all is especially important for the beamline experiment. It'll provide additional service that doesn't conflict with the existing toolkits that using the XLDB. For the HDR5, but also you know that it's also related to the today's discussion. So this is really the hybrid solution, the hybrid environment, combining to the databases and the file system. So we expect, so we need to really run that quite complex data mining procedures as well, in addition to XLDB using the different technologies. Thank you.